Hey everybody, this video is to help you learn how to do a linear regression. Linear regressions are helpful when you have a set of data, like we have the one shown here on how many photos were taken in the Grand Canyon and how many the photographer decided to keep. So this data was collected, and then it's helpful to be able to analyze this data so that you can then make predictions using this data. So if I was going to plot these points, they would fall on a graph and look something like this. I didn't exactly plot it. I just kind of randomly put dots, but roughly they would look like that. So the goal is, after we plot it, what we're trying to find when we do a linear regression is we're trying to find what we call is a line of best fit. It's the line that would go through this data if we were able to calculate what is the linear equation that would best fit this data, if this data was linear. In this case, it is. So that's what we're going to do today, because once you know that pattern, then you can use that linear equation to make predictions about future events. So for example, we knew that the photographer took 200 photos. We could get a good estimate of how many photos that they kept. The first thing that you want to do when you are doing a linear regression is to turn your stat diagnostics on. This is going to help you get your correlation coefficient so you can see how well the data fits the equation that you get. To turn your stat diagnostics on, if you have a TI-84 like the one shown here, you can go to the mode button here, and you can scroll down till you find stat diagnostics, and you just select to turn it on. It's a shortcut. If you have an older calculator that is not updated, you can also find this under the catalog. If you hit second catalog, you can scroll down to the D's till you find diagnostics. It's under D, diagnostics on. So that's two ways to turn it on. Either way, once you get it turned on, it's on for the rest of the time that you're using the calculator. So you only have to do this one time. Another thing that's helpful to turn on while we are doing this is if you go under Stat, you can click Second and then this Y equals. You'll see it says Stat Plot there. That will give you the option to turn, it says Plot 1, Plot 2. Just turn Plot 1 on, and that will show you the actual plotted points so that you can see what kind of data it looks like. You'll kind of see, if you see the data going up in a straight line, you'll know it's a linear equation. So make sure those are turned on, and then we are ready to do our regression. So the first thing you'll do is you will click on Stat, this button right here, and you will want to type your data into the L1 and L2. So put your first column, this column right here, into L1. Then you'll put the second column into L2. Make sure you carefully type in each number, because if you type in a wrong number, it's going to give you a completely wrong equation. Remember, garbage in and garbage out with computers. So carefully type them in and check and make sure you got all your data entered in correctly. Once you have done that, in order to get the equation that is shown here on my screen, is to go ahead and hit Stat again, the same button, and then you will go down over to Calc, overwrite one to Calc, and down to option number 4, which is LinReg, because this is a linear regression we are running. You will hit Enter until you get an equation, and you will get an equation that looks like this. You will notice that this is in a linear format. You can plug in your A and B in for the A and B to have your equation. Generally, I say to round to the nearest hundredth, which is 2 decimal places, but you may need to do more if it is helpful for your regression. But in general, always round to 2 decimal places so that you have a fairly accurate equation, and it'll help you do better predictions. So unless your teacher says otherwise, round to 2 decimal places. So in this case, I would round to y equals 0.33x for the A, plus for the b, I would round it to, well, I shouldn't put a plus because it is a minus sign there. So I'll do a minus 11 point, and I'm going to round that to 3 would be a good equation for this data. Of 0.85 if we rounded. If you went to the graph, you would see your points plotted here, and we can see that it roughly is a linear equation, as we had expected, because we expect that the more photos that the photographer takes, probably the more photos that they're going to keep. And again, if we took that equation that we just got and type it in, it will show that the line is going roughly through those points, and it shows you where it goes. So you can see it goes pretty closely through there. Now, there was one last thing that you can do, and you will notice on your equation right below it, we had an R. So we had an R value of 0.85 if we rounded it. And that number is very helpful to know, the R value, because this tells us how closely correlated our data is. The closer to 1 that number is, the better our data fits the equation. So that is pretty close to a 1, which means this is closely correlated. And this is a positive correlation because we notice it's going up and to the right. Anything that is above about 0.7 is a good correlation. Anything less than 0.5 is definitely a very poor correlated equation. So that's how you run a regression. Practice it a few times and remember to be very detailed in typing in those numbers so you don't make any mistakes.